guys to skip forward. Page 32.
You said?
Yes. I want to describe the attributes of the four basic parts of an electrical circuit before we build some. Power supply is the source of voltage, also known as electromotive force. Power supply is the source of voltage or electromotive force. In the case of utility supply power, which is coming from the wall, our power supplies are always capable of providing a limited amount of current. We just got done saying that the power supply from utility is essentially unlimited. What gives? It is unlimited, but we put limits on it. Every one of these circuit breakers right here is putting a brake or a limit on the amount of current allowed to flow out of it. The wires that are connected to that circuit breaker are forming part of the power supply for that circuit. So this one right down here that I got my finger on is a 40 amp circuit. This one up here at the top is a 30 amp circuit. This one is capable of supplying more power than this one is. This one over here is a 20 amp circuit. This one's even less. If it weren't for this circuit breaker right here, the utility would supply all of its power down the skinny little wires that are attached right here. And that would overwhelm them and they would melt. So the circuit breaker is there to provide a limited amount of current, therefore a limited amount of power. Have you ever been talking to an electrician or one of your guys or another electrician and they say something like, you don't have enough power there, or there's not enough power in the building to support the addition of this equipment, or something like that? You're nodding your head yes. What they mean is the source circuits aren't physically large enough to carry the required amount of current. That's what they mean. So in order to compensate for that, when we're going to do a panel upgrade in a house, we're going to remove that whole panel and put one in that's physically larger so we can handle more amps. The wires that feed it are going to be physically larger so they can handle more amps. We're not changing the voltage, we're upsizing the diameter of the wire so they can handle more current so they can supply more. It's always going to be limited by something, and that's the physical size of the wires, and that's protected by the circuit breakers or overcurrent protection devices.
So the wires you change to upsize the panel is only, I see they connect them to what's feeding from the
pole.
The pole, yeah. And so you don't have to change going like up to the pole to the pole or whatever.
Sometimes you do.
Oh wow.
Yeah. Yeah, sometimes you do. It depends on the power supply circuit, and in some cases, even if we're doing like a whole different style of building, we're going to tear this one down and build like another building 10 stories taller. It's going to use 10 times as much power. The pole is going to have to be upgraded.
Oh.
A new transformer is going to have to be installed.
So for example, that's a common one we get on the plumbing side. Oh, I want to go to electric tankless. Well, electric tankless, the average house is not equipped with the sizing for that power. And, you know, electric tankless you can do either so many amps on single phase or less amps on 3-phase, but a lot of the time they don't have that availability because the average amperage for those is 80 amps, and the house is already being used for that amount.
So if you see, like, I saw a note up over here about paying attention to FPE breaker panels in homes. Those are older homes, breaker panels made by Federal Pacific Electric. they had an issue on the circuit breakers and the connection points between the breaker and the panel degrading over time. And as the connection point in any electrical circuit is loosened, it's not as tight, that adds resistance to the circuit. So as the electricity passes through that loose connection, that's a point of resistance that generates heat, which leads to a fire, or leads to the whole panel melting down. That's the best case scenario. And that's the reason why you keep your eye out for those FPE panels to change them out. In a lot of older homes, especially like Fort Collins and in Loveland, I was driving around, a lot of homes built in the 1950s, from the looks of the 40s and 50s. And a lot of those homes originally had 60 amp service, is what it's called. The feeders feeding the house are capable of supplying 60 amps of current. The circuit breaker panel is capable of supplying 60 amps total of current. You add on air conditioning or add on a tankless water heater, you don't have enough power capacity in those existing lines to feed the new additional power requirement. Or if you're going to add a jacuzzi or something like that. Those are some all good reasons to have to upgrade the panel to a physically larger power capacity. I like where this is going, guys. Means of control. Normally that's a switch, but not always. Usually that's a switch. A switch is going to apply or remove voltage from the load, but that's kind of actually a misnomer. Actually, it's more specifically allow or disallow current to flow through the circuit. It's really what the means of control does. Not all means of controls are switches. And as we move more and more into the digital age, it's becoming more and more of a thing. A lot of our communicating controls don't necessarily have switches. Instead of their outputs, they have a device called a triac. When we have a switch, we actually have two physical things that are physically separated from one another, and then they physically come together to make contact. Physical contact. We call that a switch or a set of contacts. Open contacts, closed contacts. No current flow, yes current flow. High resistance path, low resistance path. OL on the meter, 0.3 on the meter. Follow me? A triac, on the other hand, doesn't have any moving parts at all. It's a solid state device that changes the resistance between 2 points from a high resistance to a low resistance. A balancing relay is also a means to control a load, but it's an old-fashioned type of thing that deals with the current in one winding versus the current in another, causing something to shift back and forth, kind of like a pendulum, which will modulate the motor. We don't see those very often anymore. Those are like antique 1920s kind of stuff.
So triac controls by controlling resistance.
Mm-hmm.
So is that what you call the little end cap on the end of a heat trace wire? It's got gel in there that adjusts the resistance, and that adjusts how hot the.
I honestly don't know.
Yeah.
I would love to know. It's a good question. I don't know. The switch is going to cause the load to operate or not operate as long as everything is working correctly, and switches are classified by poles and throws. Raise your hand if you've ever been confused by the notion of poles and throws. Yeah, me too. We're going to clear all that up. Power supply, voltages in the field. How do you recognize one voltage from another before you get your meter out, so you know what to expect? There are color codes present. They're not always followed, but when they're followed, this is what they are. For 120 volts AC single phase, you have one colored wire and one white wire. The white wire should be the neutral or 0 volts in relationship to ground. The colored wire should be your hot one or 120-ish volts in relationship to ground. The color of the colored wire can be any color. Usually black, because that's the most common, but it's not always black. Sometimes it's blue, sometimes it's red, sometimes it's pink, purple, brown. 208, 233 phase, one black, one red, one blue. They could all be black wires with some red tape on one and some blue tape on the other to make black, red, and blue. 240 single phase, two colored wires, any color. They are probably going to be the same color. Two blacks, two reds, one black, one red. One red, one blue. Two pinks, one pink, one orange. Probably going to be 240 single phase. 277 single phase is the same color as 120 single phase, which is why in commercial buildings it's so potentially dangerous, because people think it's this, and it's literally 3 times as much power. No, it doesn't seem like it, but it is a killer. One colored wire, one white. 483 phase, one brown, one orange, one yellow. You open a panel and you see brown, orange, yellow, you're looking at 483 phase. Make sure you have your gloves, your safety glasses, your PPE, and you're being safe. Yes, sir.
On like a 480 volt, what kind of gauge wire would you expect?
Depending on how much current the device is going to consume. It's another kind of potentially misleading things about high voltage circuits is they typically have smaller diameter conductors than low voltage circuits do, because they're going to carry less amps to do the same amount of work, or what we covered before lunch. So in that situation, your 480 volt circuit is going to have smaller gauge wire than your 240 volt circuit doing the same amount of actual air conditioning. So if you see big fat wires, you're probably looking at 240 or 208, 230. If you see small skinny little wires, you're probably looking at 480. It's a common misconception to think small wires, no problem. In fact, small wires often equal high voltage.
But you see more in the commercial part of this, right?
Yeah, you're never going to see 480.
Because in residential, it's you're getting a bigger gauge as the higher tonnage. Let's say, for example, a 5-ton will pull more amperage than a 2-ton, so your wire's thicker, correct?
That's right. It's all about the amps. The larger the capacity of the unit, the more work it's doing, the more current it's going to consume. So a 5-ton unit is going to consume more power than a 2-ton unit. More amps. Same voltage between the two of them, all right? They're both 240 volts. This is a residential 240 volt power supply. This is what's behind the panel. I've got 2 conductors, both of them colored. They happen to be different colors. But this is my 240 volts coming into the house. So if I were to measure voltage between that point and that point, I would measure 240 volts AC. This third conductor over here, this is the neutral. This is the current carrying conductor that's going to take all of my my branch circuits, my single phase branch circuits, all these neutrals coming back, all combined, will be current on that wire. So here's an interesting